Hey, welcome back to your favorite trigonometry class. We're going to take a look at sum and difference formulas. Here's a couple for the cosine. Cosine of alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta, and so on for the cosine alpha minus beta. In fact, don't get too worked up about this, but I want to show you where this formula comes from, cosine alpha minus beta. If you can imagine taking the unit circle for a minute. And let's say we had um, an angle alpha, and so its point right here would be cosine alpha sine alpha. And then let's say we have an angle beta here. So here's beta. So its point here, cosine beta sine beta, sine beta, that point right there. So obviously this angle right here be alpha minus beta, right? That much angle, like if alpha was 120 degrees, beta is 30 degrees, then alpha minus beta, that'd be 90 degrees, 120 minus 30, right? Now, let's also go, let's take a unit circle, and what we're going to do here is, if you can imagine, taking um, taking that alpha minus beta and rotating it so that this point, let me call this point 1 right here, and let me call this right here point 2. So point 1 rotates down to, on the unit circle, 1, 0. Okay, I'm going to call that point A. And so here's our alpha minus beta angle, alpha minus beta. And so again, so we've rotated that around, if you can imagine taking that whole thing around and putting point 1 on 1, 0. And then I'm going to call this point 3 right here. So this would be, this point right here would be cosine alpha minus beta sine alpha minus beta. Okay, and what I'm going to do here is I'm going to find the distance between those 2 points. Okay, so the distance between point 1 and point 2. And I'm going to show that it's the exact same distance as the distance between A and point 3. So the distance between A and, point 3. Alright, so this distance right here is, I'm going to set that equal to the distance between point 2 and point 1. So I'm going to use the distance formula. Square root of x2 minus x1 quantity squared plus y2 minus y1, okay? So let's do it. So first I'm going to use these points there. So distance between A and point 3, so I got square root of cosine alpha minus beta minus 1, so that's x2 minus x1 quantity squared, plus y2, so sine alpha minus beta minus 0 squared, okay? That's supposed to be equal to, now I'm doing this one over here, okay, that distance. So over there I got cosine alpha minus cosine beta, x2 minus x1, cosine alpha minus cosine beta quantity squared, so x2 minus x1 quantity squared plus y2, so sine alpha minus sine beta quantity squared. Now I'm gonna square both sides, get rid of this the square root there, and then I'm gonna start expanding or foiling this, right? So let me expand that, so I'd have cosine squared alpha minus beta minus 2 of those cosine alpha minus beta is plus 1 plus, and then I got sine squared alpha minus beta equals. Now I'm going to FOIL this one. So I got cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. And then let me do this one down below it. FOIL that. So I got sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Now notice that's 1, that's 1, and then I've got this minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Over here, notice I have cosine squared alpha minus beta plus sine squared alpha minus beta. So I got 2 minus 2, because I have that's 1, and notice I have that plus the 1. I got 2 minus 2 cosine alpha minus beta. Okay. Now notice also that the 2's cancel, so that cancels those. And so we have negative 2. Let me bring this up here. Negative 2 cosine alpha minus beta equals negative 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Divide by negative 2, everything. So cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. And there you have it. Okay, so that's where that comes from. Again, don't get too worked up about that. I just want to show you this is mathematics. This is so they don't just appear out of nowhere. These formulas, they are proven. That's what sets mathematics apart from the other sciences. It's very neat. You have this deductive proof involved. So, can we use this to find an exact value of cosine 105? 105 degrees is obviously not on your 105 is not on your unit circle, but we have this. We have the fact that we can look at our unit circle and say, well, do I have two angles that might add up to 105 that are actually on my unit circle? I say, well, sure, I have. Isn't 105 the same as 45 degrees plus 60 degrees? Sure. So I can use the cosine of alpha plus beta formula, or some formula is cosine alpha cosine beta minus sine alpha sine beta. So I'm going to follow that. My alpha is 45, my beta is 60. So this will become cosine 45 degrees cosine 60 degrees minus sine 45 degrees sine of 60 degrees. I know the cosine 45 degrees is root 2 over 2. I know the cosine of 60 degrees is a half. Sine 45 degrees, root 2 over 2. And then sine 60 degrees, root 3 over 2. So we got root 2 over 4 minus root 6 over 4. So you can either write it like this, or root 2 minus root 6 all over 4, either of those. Alright, how about 5 pi 12ths? Cosine 5 pi 12. So again, you're thinking to yourself, well, gosh, do I have a summation or a difference on my unit circle of a couple that will either sum up to 5 pi 12ths or whose difference is 5 pi 12ths? And I say, well, gosh, yeah, isn't pi 6 same as 2 pi 12ths? There's pi 6. So 2 pi 12ths plus 3 pi 12ths would work. That's our pi 6. That's our pi 4s. And then we're just using that same formula. We're going cosine alpha plus beta. We have cosine alpha plus beta. Cosine alpha, cosine beta, minus sine alpha, sine beta. And that's what we're going to do. So this is cosine 2 pi 12, so pi 6. Cosine 3 pi 12, or pi 4, minus sine pi 6, and then sine pi 4. So we got cosine pi 6, we got root 3 over 2, cosine pi 4, sine pi 6, we got a half, sine pi 4 root 2 over 2. So we got root 6 minus root 2, this is all over 4. Okay? These cofunction identities are interesting. You know, the cosine, if you remember these, if you use cosine alpha minus beta, that would be cosine alpha cosine beta plus sine alpha sine beta. So this is saying, you know, here's your alpha, here's your beta. Cosine pi halves cosine theta plus sine pi halves sine of theta. Well, we know cosine of pi halves is 0, so that's gone. And then we know sine pi halves is just 1. So we just end up with sine of theta. As you can use the sum difference formulas to prove those cofunction identities. Alright, here's the ones for the sine. So let's do it for sine pi 12. So I know that sine of 3 pi 12, which is pi 4, minus pi 6. In other words, 3 pi 12 minus 2 pi 12. That's the pi 12s, right? But I'm going to think about it as pi 4 minus pi 6. So I'm going to use sine of, or you know what, let me write it right here. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. And we have 3 pi 12 minus 2 pi 12. In other words, pi 4 minus pi 6 will work. That gives you pi 12. So sine pi 4 cosine pi 6 minus cosine pi 4 sine pi 6. Root 2 over 2. We know that the cosine of pi 6 is root 3 over 2. 2 over 2, sine of pi 6 is a half. So this ends up being root 6 minus root 2 all over 4. That's the sine. That's the sine of pi 12. Right? Because we're getting this with exact values, so that's why we want to use these sum and difference formulas, not just an approximation. Of course, we can punch it into our calculator, right? But we want an exact value here. All right, how about this one? This is sine alpha cosine beta plus cosine. It looks like that's alpha and sine, because betas we named as 15. So who's sine alpha cosine beta plus cosine alpha sine beta? We say, oh, that's sine alpha plus beta. So in this case, alpha is 75 degrees, beta is 15 degrees, so that's the sine of 90 degrees. Well, we know the sine of 90 degrees, right? We're right here on the unit circle. Sine is 1. So we got 1 on that, all right? All right, let's keep going here. All right, what if we got this set up here? Sine alpha, we want to draw a picture of alpha, and then I'm also they're giving us some information for beta. So I'm going to draw a picture for beta as well on this one. So sine alpha is first information is root 2 over 2. And it looks like alpha is less than pi but greater than pi half. So I'm going to draw that into quadrant 2. Now remember, sine is opposite over hypotenuse. All right, so here's root 2 over 2. And then I go ahead and solve with my Pythagorean theorem these remaining sides. So a squared plus b squared equals c squared. And b ends up being plus or minus root 2. And I'm going to name it root 2 because I'm using right triangle trig to do this, right? I know this is a reference angle, right triangle trig, so I have to kind of jimmy rig it, right? I know that's a distance, but I'm going to name it negative root 2 because in quadrant 2, my cosine has to end up being negative. So I got to name that a negative x right there, okay? And then, so that was for alpha. That was for alpha angle. Now what we're going to do is we're going to go use this information. Sine of beta, negative a third, and it's greater than pi, but less than 3 pi half. So this goes into quadrant 3. Okay, here's our beta. So there's our reference angle, beta prime. Again, sine is opposite over hypotenuse. So opposite, negative 1, hypotenuse 3. Go ahead and solve for your remaining side. A squared plus b squared equals c squared. We got plus minus root 8 or 2 root 2. Now it's got to be negative 2 root 2 because your cosine is negative into the third quadrant. Okay. Now we can answer all our questions from here. So part A, what's the cosine of alpha? So I'm looking over here at alpha. I say cosine is adjacent over hypotenuse. The adjacent side is negative root 2. The hypotenuse is 2, so negative root 2 over 2. B, what's the cosine of beta? Adjacent over hypotenuse. Now I'm looking at beta using reference angle beta prime. Adjacent over hypotenuse, negative 2 root 2 over 3. C, cosine alpha plus beta. Well, we know cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha, fill it in. Cosine beta, fill it in. We just found that, negative 2 root 2 over 3. Minus sine alpha, we were given sine alpha, it was root 2 over 2. Sine beta we were also given, that was negative 1/3, or of course you look at the picture that we created it from. So now we multiply, so negative root 2 times negative 2 root 2, so I got 2 times 2, I got 4, 6 plus root 2 over 6, so I got 4 plus root 2 all over 6. Now last one, sine alpha plus beta, which we know that as sine alpha cosine beta plus cosine alpha sine beta. What's the sine of alpha? Root 2 over 2. What's the cosine of beta? Negative 2 root 2 over 3. What's the cosine of alpha? Negative root 2 over 2. What's the sine of beta? Negative 1/3. So we got negative 4/6 plus root 2. So negative 4 plus root 2 all over 6. Or root 2 minus 4 all over 6. Alright, I'm going to stop right there and do another section.